In this video, we will solve for change in position. It's how far you've gone when you're accelerating, and we'll also solve for time for an object that's accelerating. So here's our equation. Delta x, that's your change in position, how far you've gone, equals v naught, that's your initial velocity, times the time you've been accelerating for, plus 1/2 times your acceleration times the time you've been accelerating for squared. So let's look at this example. If I'm running at 2 meters per second and then accelerate at 3 meters per second squared for 4 seconds, how much distance will I cover? So we just gotta plug and chug. So here we go, here's my equation. And remember, this is an equation that you use when you are accelerating. Okay, so my initial velocity is 2 meters per second. The time I'm accelerating for is 4 seconds. So I'll put that in there for t. 1/2 times my acceleration, which is 3 meters per second squared, times my time again, 4 seconds, squared. Okay, so my 2 times 4 will give me 8 meters per second times seconds. These seconds will cancel out, I get meters, plus 1/2 times 3 times 4 squared, that's 24. My units here are seconds squared. They'll cancel out with the second squared on the bottom here, leaving me with meters, which means the total distance I cover is 32 meters. So another thing we can do is say, well, in the event that v naught t is 0, right? If this is 0, if just v naught is 0, no initial velocity, so you're starting at rest, then this whole thing becomes 0, right? Because 0 times your time is going to be 0. So if v naught is 0 meters per second, the equation becomes delta x equals 1/2 at squared. Now I can rearrange this equation and solve for t. So let's multiply both sides by 2 first. Right, so this 2 and this 1/2 will become a 1. Then I can divide both sides by a. And then this a will take out this a. Okay, here's the tricky part. If I have t squared, to just make it t, take the square root. Okay, so what I'm left with here is t equals the square root of 2 delta x over a. Remember, this only works if v naught is equal to 0, because that takes away this part for us. So let's do an example. Remember, so this works if something is starting at rest. So let's say, a lot of times we'll use something that's dropping. So let's say an apple drops 10 meters and accelerates. So when things are dropping, their acceleration is 9.81 meters per second squared. That's the acceleration due to gravity. How long will it fall? How long will it take, rather? Okay. So here we just, again, plug and chug. We get t equals square root of 2 delta x over a. That's the square root of 2 times our distance, 10 meters, over our acceleration, 9.81 meters per second squared. So if you do that out, you get 1.43 seconds. So that means that it takes 1.43 seconds, sorry about that again. It takes 1.43 seconds for something to go 10 meters if it's accelerating at 9.81 meters per second